So this is the Explortle Careers in STEM, and we're going to dive into the world of engineering. So look around you, the buildings you step in, the roads you travel in, technology that powers your devices, and even the medical advancements that save lives. All of these exist because of engineering. Engineering isn't just about equations and blueprints. It's about innovation, problem solving, and shaping the world around us. But what exactly do engineers do? And how do they make an impact? Let's dive in the world of engineering and explore its career paths. Engineering is a vast field with specialized careers that focus on everything from launching rockets into space to making sure we have clean drinking water. Not all engineers build bridges or design machines. Whether you're passionate about technology, sustainability, healthcare, or infrastructure, there's an engineering career for you. Let's take a closer look at some of the most exciting engineering careers and what makes them unique. First up, we have aerospace engineers. Aerospace engineers focus on designing, developing, and testing aircraft and spacecraft. They work in places like NASA, private aerospace companies, research labs, and universities. Their work environment is a mix of offices, labs, and testing facilities. This field blends mechanical, electrical, and material engineering to create and improve air and space technology. Next up, we have agricultural engineers. These engineers develop technology to improve farming, irrigation, food production, and soil conservation. You'll find them working with agricultural companies, equipment manufacturers like John Deere, government agencies, and research institutions. Their jobs take them to farms, labs, industrial plants, and even rural areas. They apply environmental engineering to make agriculture more efficient and sustainable. They also apply mechanical and electrical engineering, as mentioned with the aerospace engineers. Up next, we have biomedical engineers. Biomedical engineers design medical devices, prosthetics, imaging systems, and even artificial organs to improve healthcare. They often work in hospitals, medical device companies like Medtronic, research institutions, and regulatory agencies like the FDA. Their expertise blends medical, electrical, and chemical engineering to advance medical treatment and patient care. Next up, we have civil engineers. Civil engineers are behind the planning and construction of infrastructures, things like roads, bridges, buildings, and water systems. They work with engineering firms, construction companies, and government agencies. Their job takes them from offices to construction sites, ensuring projects are structurally sound and sustainable. This is one of the oldest engineering fields, incorporating structural integrity, material science, and environmental considerations. Last but not least, we have environmental engineers. These engineers tackle environmental challenges like pollution control, waste management, and water treatment. They often work with consulting firms, government agencies like the EPA, renewable energy companies, and nonprofits. Their work environment varies from offices and labs to field work at contaminated sites and water treatment plants. They apply chemical, civil, and mechanical engineering to protect the environment and public health. Finally, we have agricultural engineers. Agriculture engineers focus on technical aspects of buildings, ensuring they're structurally sound, energy sufficient, and functional. They handle things like HVAC systems, electrical wiring, and lighting. You'll find them in engineering and architecture firms, construction companies, and research institutions. They combine civil, mechanical, and electrical engineering to design safe and sustainable buildings. As we mentioned in our previous video, STEM is a foundation of innovation. Within engineering, some fields rely more heavily on complex math and science to push technical advancements forward. These STEM-heavy careers require analytical thinking, creativity, and a passion for problem solving. So, which engineering careers are the most STEM-intensive, and what does it take to succeed in them? One of the most STEM-focused careers we've discussed is aerospace engineering. As previously mentioned, aerospace engineers design, develop, test, improve, and analyze aircraft and spacecraft. But what does it take to become one? To enter the field, you'll need at least a bachelor's degree in aerospace engineering or related fields such as mechanical, electrical, and materials engineering. While entry-level positions don't require certification or licenses, experienced engineers can earn a professional engineering license abbreviated as PE. To obtain this license, engineers must do the following. First, earn a degree from an ABET accredited engineering program, pass the fundamentals of engineering exam, gain several years of relevant work experience, and pass the PE exam. Aerospace engineers typically work in office settings using computers for design and analysis. Most work full-time, and some even exceed up to 40 hours per week. If you're considering this career as a high school student, you should focus on chemistry, physics, and advanced math courses. It's also helpful to develop key skills such as analytical thinking, which is an already developed skills through the years of education, business and communication skills, interpersonal and problem-solving skills, and strong math skills. Now let's take a look at the salary and job outlook. Aerospace engineers earn a median annual salary of $130,720 as of May 2023. The field is projected to grow 6% from 2023 to 2033, with approximately 4,200 job openings per year over the decade. Now, I have a question for you guys. Based off of all the engineers I've previously said in this video, take a guess which career designs and develops medical devices, prosthetics, imaging systems, and artificial organs to improve healthcare technologies. That would be a biomedical engineer. And this is going to be our second STEM-heavy career that we're going to talk about today. So to enter this field, biomedical engineers typically need a bachelor's degree in bioengineering, biomedical engineering, or a related field. Some positions may even require a graduate degree. Though certifications and licenses are not required, biomedical engineers can earn 2 levels of licenses: the Engineering and Training EIT or the Professional Engineer PE. And if you haven't seen the patterns yet, all engineers at a higher level of engineering do require professional engineering, the PE certification. And having these credentials can open higher paying jobs and better career opportunities, while also proving expertise and commitment to the field. Biomedical engineers work in manufacturing, research facilities, and other healthcare related industries. Like aerospace engineers, they work full-time and some exceeding up to 40 hours per week. To prepare for this career, high school students should focus on science and math courses. If available, take drafting, mechanical drawing, and computer programming. Important skills for biomedical engineers include analytical and problem-solving abilities, communication and creativity, and strong math skills. Now let's take a look into the salary and job outlook. As of May 2023, biomedical engineers earn a median annual salary of $100,730. The field is expected to grow 70% from 2023 to 2033, with around 1,400 job openings per year over the decade. Now that we have explored different engineering careers, it's time to put your knowledge to the test. Answer each question carefully, and let's see if you have what it takes to think like an engineer. Question 1. Which engineering discipline focuses on the design, testing, and development of both aircraft, spacecraft, ensuring they meet the required safety, performance, and regulatory standards? So the answer is definitely B, aerospace engineer. Aerospace engineers design, develop, and test spacecraft, aircraft, satellites, and missiles. They focus on aerodynamics, propulsion, and flight systems. Question 2. What is the primary focus of agricultural engineers? The correct answer is C, improving farming equipment and irrigation systems. Agriculture engineers develop technology and equipment to improve farming efficiency, including irrigation systems, soil conservation techniques, and automation in agriculture. Moving on to question 3. Which of the following workplace is most common for biomedical engineers? The correct answer is D, hospitals and research labs. Biomedical engineers work in hospitals, research institutions, and medical device companies, developing technologies such as prosthetics, artificial organs, and medical imaging systems. Up next, we have a true or false question. Civil engineers are responsible for designing and building medical devices. The correct answer is false. Civil engineers work on infrastructure projects while medical engineers focus in medical device design. Last but not least, we have question 5. Environmental engineers focus on. The The correct answer is D, reducing pollution and managing waste. Environmental engineers develop solutions for environmental issues such as water and air pollution control, waste management, and sustainable energy systems. Finally, we have another true or false question. Agricultural engineers work on electrical, lighting, and HVAC systems on buildings. The correct answer is false. While agricultural engineers focus on engineering systems within buildings, including light, electrical, HVAC, and plumbing, architects primarily focus on design and aesthetics of buildings. And quick fun facts before we end this video. Engineering isn't just about formulas and technical drawings, it's full of surprises. Did you know that some of the tallest buildings in the world can sway in the wind, or that biomedical engineers are working on 3D printing human organs? Get ready to discover some of the most fascinating and unexpected facts about each engineering career. Now I'm going to talk about 3 facts that I saw was interesting. So first we have aerospace engineering. I think everyone has this stereotype that when you work for NASA, you're only working for the spacecraft and just building spacecraft and sending people out in space. And we're here to break that stereotype. Aerospace engineers also work on improving air traffic control systems, designing drones, and developing supersonic commercial jets. Another fact I saw interesting was that 3D printing has helped biomedical engineers print prosthetic limbs and even human organs in the future. And I think this will greatly help our future as we blend the medical and engineering factor together and create solutions for medical problems such as losing a limb and figuring out certain diseases that are still unknown to us right now. One last fact that I'm going to talk about before we end this video is that a hospital located in Mexico City has a special coating of smog that breaks down air pollution. This makes the world's first smog-eating building to exist. And I think this is really interesting because air pollution has been a really prevalent issue in our society right now, and I think these innovations are really opening doors for more possibilities. And yeah. From designing airplanes to developing life-saving medical devices, engineers are the creators of the future. They solve problems, improve our daily lives, and push boundaries of what's possible. Whether you dream of working with high-tech innovations, sustainable solutions, or massive construction projects, engineering offers endless opportunities. So, what kind of engineer do you want to be? Let us know, and that is it for today's video. Thank you. Make sure to keep in touch with us on Instagram at Explortle or through email explortle@gmail.com.